Hello guys, welcome back. So let's move on to regulate our points. So basically we want this point to be on a fixed number, like their x and y, z will be a number of 1, 2, 3 or 4, but nothing in between. But now they're like in all random places. Okay. Alright. There are various ways to do this, but I'm gonna try this one way called attribute wrangle. You can just hit tab and say AW, and that's gonna pull up this attribute wrangle here and just click to position it and connect that over here. Alright, that's another strength of Houdini. You have access to all possible attributes from a geometry in whatever way, in whatever format, and also you can add custom ones. And attribute wrangle is one of the things you can deal with those attributes and using a way of coding. Okay, now this may be scary, but the programming in Vex is fairly simplified. It doesn't have any complicated concept. It's basically the old school, merely anything that we do with the C programming language. All there is procedural, right? There's no class, no pointers, no whatever. It's just procedurally making code to do something. Okay, but the good thing is that you can run over different things, like run over every points, every primitive, every vertices, and every numbers. So point and vertices kind of like the same thing to many people, right? That the difference is that point is one and only. If you toggle the point, you can see, there's a bunch of points. Those blue ones are points. Okay, so vertices, on the other hand, are reference to points. Okay, because sometimes you have like this primitive, right? This face, we call that primitive, and it has 4 vertices. But on the other hand, its neighbor here also have 4 points, right? 4 vertices also. But you can see they share the same point, right? But they share different vertices. Their vertice is actually the way they reference to the point they're sharing. Okay, but that shouldn't make any different in our case. So if you wanted to advance more, you can look at the documentation on the explanation on what those are different. But we're gonna run on the point, okay, because there's a real thing. All right. So anyway, so I'm gonna go say at position. This at means attribute, and position is uppercase P, position, so meaning the position of the points, because we're running over every individual point. We're going to say there dot x, the x-axis or position of the position P, right, of the point position, will be equals to a rounded up rint, which is a function to run up whatever you give it. And then we're going to say the position of the x. Okay, what this does is basically saying, okay, no matter what your position is on the x, I wanted to make it a rounded up version of itself. Okay, basically converting it into an integer. Do the same thing for the y and z. Okay, which will result in all the positions on our axis will be a fixed even, not even a fixed integer number. Okay, around this you can see how our stuff changes, right, which is pretty cool. Okay, now if you go back here to the curve node, you can move on to the viewport and hit space, enter. You can still edit this curve. You can drag things longer. You can see how it's being able to go through the whole process and generate the final result. You can hold it down shift and click to add new ones. You can see how we are still able to edit our stuff, right? And it's able to update. Okay, you can try this diagonal one. You can get something really weird, right? I don't want that. It's capable of doing something, but it's not ideal, right? Anyway, so we can do all these things. Okay, but you can see, if I control Z back here, you can see, well, there could be problems like this, right? A diagonal line. Now that's not very cool. I want to have even grade, but I have diagonal lines from time to time. Well, that's annoying, right? So we're gonna have to fix that. Okay, so let me hit enter us to finish this. Now let's deal with those diagonal lines. Okay. So one of the interesting feature of those diagonal lines is that they're basically essentially longer than the other lines. Okay, so what we can do here is we can do like a group node. Okay, connect that to the group. A group node is basically a node that allows you to give different things a group. It's almost identical to ZBrush's polygroup. Okay, but it's able to do that not just on the faces, but it's able to do grouping for points, for edges, and we're gonna do that on the edges this time. Okay, I'm gonna call this guy bug lens or diagonal lens. Diagonal angle, no, diagonal lens. Diagonal should be fine. Okay, all right. So diagonal lens on the edge, but it's now selecting all the edges. I'm gonna check off the base group to tell it to not do anything in the beginning yet. I wanna go include by edges. Here I'm gonna say edge. Reject that thing. Longer. I'm gonna say check on the edge angle uses angle between edges. Then I can define the. Actually, I can just check that out. Yeah, check that out. The mean edge length will be the one we do. Then the mean is gonna be 1.02 or 1. Okay, because I know that those ones are 1 unit long, right? Because we snap those guys to this length, right? So it's either 1 or 2 or 3. We round those things up. Which reminds me, if you turn on the point view of the numbers, this is going to show you the number of different points. You can see we have a whole lot of points. And there are clearly a bunch of points overlapping on top of each other, and that makes sense because, well, it was like this, right? And then we snapped them. Of course, a lot of points are going to be snapped to the same position. Right, so before we do the group, I think it's much safer if we fuse them together by using a fuse node. Right, that will do much better. You can see now we're having lesser points, and then we do the group. All right, and I want to get rid of diagonal lines, but the group does that for me already. There is a group for that. All I have to do is dissolve it. Dissolve. Okay, and turn on the dissolve and say I'm going to dissolve the diagonal here. You can see now those diagonal lines are gone, which is pretty cool, right? So now we have a clean structure. Okay, now one thing to keep in mind in Houdini is that it's not guaranteed that when you set up some basic structure, it's guaranteed to work in all different conditions. Like here, the curve could be different. Now you never know if it's going to work in a strange way of layout, so it's better to do more testing. So I'm going to go to the curve and hit enter again to start editing it, and shift and click to start dragging in new ones. Okay, and see if I can produce anything problematic. I think it's doing just fine for now, so maybe later on if we see something problematic we can fix it, but for now I think it's doing just fine. Okay, we can add new ones down the way. Anyway, so yeah, that's going to be the second step. We just used a few more nodes. We introduced attribute wrangle, right, to regulate the position, which is kind of like pretty cool. And in the next video, we're going to go ahead and try to move on from here and maybe make a floor out of it, right? This is a space. You actually make a sci-fi corridor out of this, right? That's totally cool. But we're going to focus on doing like a flat surface. You can see there's some problem here though. Some faces are overlapping. So yeah, we can fix that real quick. I think there's a clean node, and you can tell the clean node to remove the overlapping. Yeah, fix overlap. Just gonna delete all the overlapping faces, which is pretty convenient. All right, now that's much cleaner, and we can move on now to the next video where we keep on going with this setup. Okay, see you next time.